Alright, so we're here to talk about the distance formula. We've got 2 points on a Cartesian plane, and we want to know how far it is between them. We want to know the distance of that line. Let's just call that line x. Okay, how are we going to do that? Now, even if you don't learn anything from this video, even if you don't remember the distance formula I give you today, you should still be able to find that length because you know somebody named Pythagoras. So, the distance formula is really just an application of Pythagoras' theorem. We have a point here, we have a point here. Now I'm just going to draw in a horizontal line, and I'm going to draw in a vertical line. You can see this line is parallel to that line, and that line is parallel to that line. Now, a horizontal line and a vertical line meet at a right angle, and now I have a right angle triangle. If I can find that length, and I think I can, and if I can find that length, and I think I can then use c squared equals a squared plus b squared to give me the answer. Now, the question is, how are we going to find that length? Now, I'm not going to jump straight to like a formula. Let's think about it. We have a point here, and the x-coordinate of that point is 5. That means that the distance from here to here, that length there is 5. And we have here an x-coordinate of -4. That says -4 there. That means that the distance from there to there is -4. Now the distance from there to there is 5. The distance from there to there is -4, but really it's 4. So 4 plus 5, that's 9 units long. Okay. And this next bit, well, this has gone down -2. That's -2 there. This has gone down -6. That's -6 right there. So the distance from -2 to -6 is 4 units long. Okay, so now I have a right angle triangle with a base of 9, or one length of 9, one length of 4, and I can now use c squared equals 9 squared plus 4 squared to find x. Now, at this point, I really do want to talk about what the actual distance formula is, even though it's really, really quite ugly. Now, don't start writing anything yet, because I'm going to change it. X squared equals whatever that thing ends up being, so let's just write it as 9 squared for now, and whatever this thing happens to be, let's just call it 4 squared for now. Okay, we're going to build up this formula. If x squared equals 9 squared plus 4 squared, then x equals the square root of that. So I'm going to get rid of the squared bit and put a square root in here. So now I've got a distance formula of x equals 9 squared plus 4 squared, but obviously only for these points. So now we need to come up with something a bit more, it works for everything. So let's call this point 1, and let's call this point 2. That means that this coordinate is x1 and this coordinate is y1. And that means that this coordinate is x2 and y2. Okay, now what did I do to find that 9? Well, I kind of took that value and took that value. But what we can actually do is subtract one of those values from the other. Watch this. 5 minus 4. That gives me 5 minus 4, which is 5 plus 4, which is 9. So, I can rewrite the 9 as one of those values. Let's use x2 minus x1. x2, -4, minus x1. That gives me -9. Oh, wait a minute, that's a bit strange. I don't want -9, I want 9. But, remember what I did there. I squared it. So, it actually doesn't matter whether I get a negative or a positive answer here, because I'm going to square it. x2 minus x1 squared. Plus, and we can do the same thing here, do it in the right order, y2 minus y1 squared. This is our distance formula. the distance is equal to the square root of x squared minus x1 squared plus y2 minus y1 squared. That's the distance formula. But really it's just Pythagoras' theorem. So now that we've done all of that, we can do that question, or maybe a question very much like it, using that formula. Alright, so this is what I'm going to do. I'm going to find the distance between negative 5, 6, and 2, negative 1. I'm going to find the distance between those 2 points. Okay, I'm going to use my distance formula to do it. Distance equals the square root of, it doesn't matter which point I choose as point 1 or point 2. I might call this point 1 and I might call this point 2. Now, if that's point 2, that's x2 and that's y2. So, in my formula, I'm going to have x2 minus x1. So, 2 minus 5 squared plus y2 minus y1, 6 squared. X is equal to the square root of 2 minus 5, which is 7. So 7 squared plus negative 1 minus 6 is minus 7. Okay, and then that means it's equal to the square root of 49 plus 49. Negative 7 squared is positive 49, which is the square root of 98. Now, doing that on your calculator, you're going to get an answer very close to 10, 9 point something. And it's really at this point that you should stop and just check that it makes sense. Alright, so the distance from there to there is 7 long. The distance from there to there is 7 long. So what I have is a triangle 7 by 7. So does it make sense that the hypotenuse of that triangle, which should be longer than the other two sides, is 9.9? Yep, that looks like it's about right. So I'm probably good there. Alright, that ugly looking thing right here is the distance formula. But don't forget, it's just Pythagoras' theorem in disguise, used with Cartesian points.